This is question 28 on the November 2013 higher calculator paper. This question says AOC and BOD are diameters of the circle whose center is O. Prove that triangle ABD and triangle DCA are congruent. So, first of all, triangles or shapes which are congruent are the same in every way. All angles and all sides are equal. And I'm actually going to write that down at the side. Okay, congruent triangles, and it actually applies to any shape, are the same in every way. Okay, so all the sides and angles are the same. And what I'm going to do, and I think the best way of doing this particular question, is just looking at each of the triangles in turn. So I'm not going to, or comparing each of the triangles. So I'm not going to try to draw an exact diagram of them, but I'm going to use a diagram of each of the triangles and sort of compare sides, angles, and just give my reasons for why they're all the same or not, and then say whether the whole shapes are congruent or not. So what I'm going to look at first of all is ABD, ABD, and ADC, ADC. Now the first thing I'm going to say is that AD is common to both triangles. Okay, so they have a common side. So these two sides are going to be exactly the same. The second thing I'm going to say is BD must be equal, so B to D must be equal to A to C, because they are both diameters of the circle. Okay, so AD and AD are the same. BD and AC are the same. The next thing that you should be able to recognize and spot is the fact that because, using the rule, because the diameter supports an angle of 90 degrees at the circumference, there are two angles on this shape, and I'll put them on the diagram. This angle here is 90 degrees, and this angle here is 90 degrees. So BAD, is equal to ADC, and both of those are equal to 90 degrees. So on my little diagrams here, that's 90 and that's 90. So what I have is two sides equal. They also have an angle that's the same, and I think I could actually get one more thing out of this. I'm actually going to say, using like the rules from circle theorems, so if we go back to the diagram up here, the rules from circle theorems say that a chord supports the same angle at any point on the circumference. So if I think about the chord AD supports this angle here at B, and that's going to be the same size as the angle at C. So this angle here is exactly the same as that angle there. And back to my little pictures here, these two angles are the same. And the reason for that is because the chord supports the same angle. Right, so the chord AD supports the same angle at any point on the circumference. And what that means is ABD is equal to ACD. So those two angles are equal. So to sum up now, because we have two angles which are the same, that actually means that all three angles are the same. Okay, so all three angles are the same. We have two sides are the same, so that means the shapes are congruent. Therefore, all three angles are equal and two sides are the same, so the shapes ABD and DCA are congruent. Now, one of the things I didn't point out, but I did recognize myself at the start of this question, was that there's a star next to the question number. And I should have made a lot bigger deal about this at the beginning, but because there was a star next to the question number, I wanted to make sure I stated everything clearly, right, and I explained all stages of my working. So I've actually numbered the points that I've made, and then at the end I said, therefore, all three angles are equal and two of the sides are the same, so the shapes ABC and DCA are congruent, and definitely the case. And there's 3 marks for this. However, again, this is the last question in the paper. It is actually pretty straightforward. And if you're aiming for an A star, these are the marks you need to make sure you get.